Hello everyone, good evening, and welcome you all to our another interesting session of Azure Developer Community. And for today's session, we have a very amazing and experienced speaker with us, Yusuf, who is from Microsoft, and he has been a very active and keen contributor in the tech industry for the last couple of years. So, before bringing Yusuf on stage, I would like to tell you about the format of today's session.
Shifali, I hope you're still there. Looks like there is some bandwidth issue or something. So, anyways, this happens every time we know, right? So, since we have moved to the digital space, so this is very common nowadays. Anyway, as Shifali was mentioning, that we have today Yusuf from Microsoft. And yes, before we start with the session, just to give you a brief on what do we have. So Yusuf is going to give a very amazing session, as we all know, and this whole session is brought to you by Azure Developer Community, which is a Microsoft powered initiative to help developers across the country to get them started with Azure and related technologies, and also to help them upskill so that they can start their developer or the tech journey, and they can empower more people. So with this initiative, we have 100 plus communities in different cities and tier 2, tier 3 places in our country, where our amazing organizers are helping developers to come out and share their knowledge and experience with other people. So similarly, today we have Yusuf, who is going to give a great session to all of you. So if you have any queries, don't feel like shy. Just drop your questions in the comment box so that he can answer after his session is done. So bringing Yusuf on stage. Hey Yusuf,
Hey, hi folks. How are you guys doing?
we
So
all are
let me
doing
get
great.
started.
Yusuf.
Yeah,
Yes, Yusuf.
you're able to see my screen?
Yes. So I will be putting your this presentation on screen, and it's visible to all of us.
Okay, cool.
All right.
So,
So, Yusuf,
hi folks.
before we start
My
the session, maybe you can give a quick introduction about yourself. What do you do at Microsoft, and what are you going to present today in this session? And then we can start with your today's session.
I'll do that right away. So obviously the title of the session is how to make best use of AKS for your cloud native applications. Let me get started with a little bit about myself. Just give me a minute. Slides as usual don't work. Okay. Did the transition happen? No.
No, Yusuf, we are still able to see your
Okay.
about
Yes.
me.
So I am a principal specialist with the application innovation team in Microsoft. I'm part of a team called as Global Black Belt Asia, where we help out strategic customers in their cloud native journey. I have about 20 years of IT experience. I started off on the Azure just about the time that it was launched, and then I've been working on it. My overall IT journey has been started from the application developer space, where I was writing applications on Visual Basic 6, moved on to .NET, and then started the architect, and then became cloud consultant, and now I'm a cloud native specialist working on predominantly containers and Kubernetes. I especially love conversations in terms of how to solve problems, how to make your applications better. I'm an avid reader, and then here are my coordinates for in case if you want to reach out to me. In terms of the agenda, as what mentioned, I'll probably do an introduction of what cloud native is, what AKS is. It's not, I already know the Azure community has sessions on Kubernetes 101. So I will advise you to go through those sessions. They are amazing, including the Kubernetes workshop. But then what I'll do is, I'll start off by thinking about what are the basic traits of a cloud native application and how do you go about implementing them. And then specifically touch around certain areas of AKS with respect to networking, scalability, DevOps, security, management, and monitoring. And then, also talk about some of the references that we have built over a period of time. Feel free to drop in your questions. I may not be able to actively look through it right now, but what I'll do is I'll keep some time towards the end and then go through all the comments and then kind of address them as required. So let me get started. If you look at how do you basically build cloud native applications, the idea is that you require organizational agility, and then there's application development. And when both of them come together, that's where we talk about cloud native applications. The idea is that you respond to changes faster, you optimize on your costs, and this cost could be just the plain vanilla hosting cost, but it could also be cost to refactor, cost to kind of make changes to your application, cost to add new features. And then how do you ship confidently with as much less errors as possible? So it's obviously a combination of application patterns, technology choices, and then practices. So in a very high level, how do you kind of look at cloud native development? Obviously, at the most bottom, we are talking about multi-layer security. We are also looking at operations that are automated as much as possible. So from kind of building your application to releasing them to monitoring to triggering any kind of resilient features inside of that, everything is automated. Software delivery, because it's automated, predominantly uses a lot of DevOps practices. Okay. And then from an application components perspective, there will be a lot of AI powered application logic, which means you're using a lot of insights. There is integration built into your application by way of connectors, APIs, API management. And then your data is a very robust part, which is like, fully managed, it's a completely isolated atomic data structure. And then on top of it, you have the cloud native architectures, which is nothing but a combination of microservices, containers. You have functions which are event driven, and they can be kind of delivered on demand. Then we have DevOps, and then APIs which are exposed. So each of your functionality is exposed as APIs. Now, why is Kubernetes so great for cloud native development, right? First, obviously, it kind of, you can say that it provides you all the necessary orchestration capabilities that you would need for a cloud native application, whether it is high scalability, resiliency, availability, the necessary health monitoring, as well as, there is a huge amount of adoption across the industry for Kubernetes. It is obviously vendor neutral, which means, historically, if you do not want to get tied to a particular stack, you can still do that. You can develop your applications in any languages that you want, and you'll still end up, being cool about it. And then there's a huge community that supports Kubernetes growth, and there've been like drastic amount of contributions to the overall Kubernetes structure. Now, however, what we've seen is when you are doing plain vanilla Kubernetes, obviously by itself is not sufficient because you need a lot of infrastructure automation to provision the underlying virtual machines, networking, storage, and data. There is also some security considerations that you would need. Governance becomes really difficult. Identity management is required to secure your applications. And then from an integration with the development part, which is CI/CD, source control repository, or container repository and all of those things. And that's where what we've realized is that if you go for a managed platform like Kubernetes on Azure, you kind of start getting a lot of these enterprise grade features by design. And that is, we've already developed the structure based on built-in best practices. We have got multi-layer security. There is operational efficiency built in inside of it, which means we will automatically provision. We can manage the underlying nodes for you. We manage the control plane for you. So you are not worried about those operational tasks. You're only focusing on building your applications and deploying them. And then, yes, it's unified management, which essentially means you can call up our support and we can go ahead and help you. And there are multiple levels of support, from an automated, support that is available through the screen, so that it gives you intelligent insights in terms of how to manage your applications on the cluster, to a proper support where you can call up, our support helplines and then get the necessary support. So, completing the introduction, now let's get down to the business. How to go cloud native with AKS. So when we look at cloud native development, right, what does it mean? It's designed for the cloud, it's developed in the cloud, and it is provisioned to the cloud. Essentially, when you talk about AKS, you or Kubernetes, you kind of exploit the capabilities of elasticity, which means your applications can be deployed on any of the worker nodes, and AKS will take care about making sure that it's available all across the board. A resiliency, which means if one of those containers goes down, AKS will bring it up back again. Availability, by way of we using the underlying virtual machine scale sets, we are guaranteeing some amount of availability. And if you go for availability zones, it's the availability specific SLAs are higher. And then the orchestration is completely managed by AKS in terms of where to schedule, how to make sure that there is optimum utilization of your underlying resources. But then there's one thing that I always advise my customers to implement, and that's trying to adapt a pets versus cattle mentality. When we look at traditional applications which are deployed on virtual machines, we always tend to kind of work through their IP addresses, what's there in those instances, and that means that there is a lot of you can say tight coupling internally there, even though you would have divided them into smaller services. But just because you are so much tied to which machine it has been deployed on, which IP address has been allocated to it, that you're still tightly coupled. So the thought process is, go ahead and make your infrastructure immutable and disposable, which means if, let's say, a particular virtual machine goes down, your application can still come up with a new IP address, with a new instance, absolutely new, and still your application still keeps on working. And how do you go about doing it? Predominantly, you look at idempotency, which means if the same operation inside of your application is happening again and again, it will lead to the same results. The second part is, if, let's say, a particular instance of that application goes down, and let's say it was processing a transaction, you need to have the necessary retry mechanisms either outside of that particular instance or that API, so that that API is invoked again. Or the second part is, before the particular instance gets killed, you can go ahead and handle the event and make sure that whatever data is required to retry the transaction is captured somewhere, and this transaction is kind of retried in the right way. Okay. The second part is, when you look at your application deployments, think of it as your application instances will also be destroyed and recreated, which means you're never updating or repairing a particular instance. You're always reprovisioning a new application instance. In fact, a lot of time I always tell my customer, go ahead and delete those individual pods and then see how your application behaves. If your application is still resilient to those changes, it means you are building a proper cloud native application. And that kind of brings me to the next part, right? That when we are looking at our design principles, it has to be more cloud native. So treat everything as loosely coupled services. It is absolutely decoupled from infrastructure components. You can build with any of the newer technologies that you have, primarily because there are so many upgrades that keep on happening. You will have container images that you will need to upgrade. The underlying platform needs an upgrade. So support is absolutely important. And if you are there on a legacy technology, you may end up facing a lot of hardships. The third is you communicate with lightweight APIs and protocols such as REST and gRPC. gRPC we've seen has become enormously famous, and that's works out fine. I'll talk about the fourth point a little later in terms of stateless and how can you achieve that. Obviously, it is containerized and orchestrated, and then you embrace DevOps and automation. A good reference that I have seen is the 12-factor application principles. If you start kind of building your applications based on these principles, that always helps. The 12 of those factors are already put across on the right hand side, and there are clear guidances and patterns around how to achieve each one of them. It's you should definitely give it a read and see how that can help you build your cloud native applications. Going specifically on data, and what we know is that there's obviously state which needs to be stored for applications, and then there's a lot of data which is there. And the 12-factor application kind of points to those as backing services. So these could be application data store, these could be message brokers, these could be distributed caches, this could be monitoring data. This could also be the identity services that are required for authenticating your end users, as well as authenticating the developers or the admins who are kind of deploying the application. So all of this, because there's some amount of data in it, we call them as backend services. And then what we generally recommend is try to move them into a managed platform for those backing services, so that it's completely decoupled from your microservices, and hence inside of your AKS cluster, these microservices can scale and can kind of move easily without trying to worry about it. In fact, tomorrow you can go ahead and change those microservices also pretty easily, because your backing services is holding all the data. Movement to DR environment or other tertiary canary deployments is also simpler when you have these backing services outside of the cluster. Now, if you're not using any of these managed services and you still want to use some kind of data inside of your cluster, you will have some Azure storage which will need to be mounted. And we have the choice of 4 storage options: Azure disk storage, which is typically what we would recommend for databases, big data solutions, high performance caches, and those kinds. Okay, it's predominantly read write on one particular instance. It cannot do read write many. With our shared disk functionality, which has been recently released, you can achieve read write many, but then that's for the newer workloads. And do make sure that you understand the necessary throughput which is required for them. The second one, which is predominantly for read-write many workloads, is Azure File Storage, and this supports both SMB and NFS protocols. It's a shared disk which can be shared across your pods. So if your pods kind of go out, get deleted, and come up on another node, you can kind of mount the file storage on on that new node and access it via the standard NFS or SMB protocol. We also have something called as blob fuse that can be used to basically use Azure Blob as a mount onto this part. Again, you can use it. Generally, we see this becoming more required when you are doing huge amount of data and you want to do a lot of analytics. And obviously the disk and file storage cost is prohibitive. And then when you have really high performance compute requirements, where you know that the IOPS is going to be huge, we strongly recommend using Azure NetApp files, and this can kind of work through the standard NFS protocol, so that it can be mounted across. Now there's also this important point of model, which is static and dynamic. Static means you are mounting the disk directly, and then dynamic means you use the persistence volume claim feature of Kubernetes and mount the individual, or basically give the control to AKS to mount the necessary nodes wherever required. You just define the necessary persistent volume claims in your pods, and you define the necessary storage classes. So I generally would always recommend the dynamic way of mounting it, unless you have certain requirements where you can not do with dynamic and you have to go for static mounting. Moving on to the next part of my recommendations is networking. And to be honest, the standard networking is already covered in workshops, so you can put across in your virtual networks. You can bring in your own virtual networks. You can kind of restrict it using the standard WAFs, NSGs. You can bring in firewall. You can do ingress. There's lots of documentation around it. But then, what we've recommended is that you implement east-west policies inside of your cluster, and you can do that using network policies, Kubernetes network policy. You also adopt like a zero trust security model. And when we say a zero trust security model, we mean that you implement your microservices connectivity as part of your CI/CD workflows. You define your baseline traffic patterns, and you also implement multi-factor authentication. And this could be, one is kind of implementing mutual TLS if required, as well as probably defining a network identity if needed, right? When you are doing data in transit, you can optionally go ahead and implement encryption of data in transit. There is definitely an encryption of data at rest, which is by default implemented. You can also bring in your own your own keys for encrypting that value. The second is, you ensure that there is significant visibility and monitoring which is there, and reporting on those areas. And then from a continuous compliance perspective, ensure that there are clear role-based access controls, and there is GitOps and policy as code, which is also implemented. Double clicking a little bit on the east-west traffic using network policy, what we generally recommend is start with a default deny all ingress and deny all egress traffic inside of your cluster, and then start allowing your communications between various pods. And generally what we suggest is go at the namespace level first if possible. And if you have multiple applications deployed in a single namespace, then what you can do is use the Kubernetes labels to kind of identify applications, and then use the selector just like what you do in services to go ahead and define those selectors in your network policies as well. Worst case, in very very rare scenarios, you should be using IP addresses. It is possible, but see if you can avoid IP addresses. Obviously for external traffic, you may end up kind of allowing or kind of denying certain IP blocks as well, which is there. Now, if you want to go a little more advanced beyond this part, and let's say you want to do a more secure encryption in transit, you can also look at something called as service mesh. And what a service mesh does is, service mesh has its own control plane, which can actually be deployed inside of the cluster or outside also, depending on what service mesh you pick up. Uh, it will give you out of the box gateway, which is for ingress. And then, it can give you out of the box discovery. You can implement authentication and authorization via simple to use policies. You can also implement, kind of restrict pod to pod communication. So it does a very interesting, at least most of the service meshes, what they end up doing is, kind of introducing a side container inside of your pod, and that starts kind of intercepting all the traffic. And by doing that, then you can kind of implement configuration in a centralized place. You get the necessary observability. You also get the necessary instrumentation very easily. And then because of the side containers, you can also build the necessary encryption, security, routing, and load balancing as well. So that's how kind of service meshes work out. We have seen some of the most secure and advanced configurations use service mesh very effectively. But then do remember, service mesh will also add on to, they will, because they also have certain components which will need to be injected, and there are there, which means your overall cluster compute requirement, memory resource requirement kind of goes up, and that also adds in a little bit of management overhead. When we talk about scale, we know that you can definitely go ahead and do manual scaling, but then we've seen that that is a little tedious and ineffective. So what we generally recommend is at the pod level, go ahead and implement a horizontal pod autoscaler. What this will do is, when you define your pods, you define the CPU and memory values, and these could be both request values and limit values. Now, the request values is what will be kind of reserved by Kubernetes, and when it allocates the pod to a particular node, and the limit value is the oversubscription that you can do on a particular node. That's the maximum amount that you can go, beyond which Kubernetes will not no longer provide any more resources to that particular pod. So I always recommend that you have your CPU, your request values and your limit values as close as possible, so that you can kind of also take the benefit of oversubscription, but do not lead to scenarios where there's too many pods trying to kind of get to the same kind of resources. But then once you've implemented those request and limit values, you implement your horizontal pod autoscaler, where, let's say, based on CPU or memory or any custom metrics, depending on how you configure it, you can go ahead and scale these pods. You can define a minimum value and you can define a maximum value, and then these pods will be scaled by Kubernetes automatically, so that you're not worried about it. So what happens is there is a metric server that we continuously monitor. As soon as the necessary metrics are picked up, the command will be given to the necessary controllers inside of Kubernetes, and then your new pods will start coming up. Now this works in tandem with the cluster autoscaler, so that, let's say, when you're increasing your pods and there is no more CPU or memory available in a particular cluster, because all the nodes have been already filled with pods, the pods will start getting into a pending state. When it starts getting a pending state, the cluster autoscaler can kick in. It can check for pending states, and if it sees that there are pods with pending state, it will go ahead and provision additional nodes. Again, just like in your HPA, you can configure what is the minimum and what is the maximum number of nodes that you want, beyond which it will no longer configure. But at least when you configure the cluster autoscaler in this way, you are rest assured that whenever an HPA triggers and if there is no more CPU available, the cluster autoscaler will bring in the necessary nodes. So do remember, cluster autoscaler does not work at the CPU and memory of the node. It works on the pending pod concept. So you have to make sure that the CPU and memory of the pods is optimally utilized. And once you do that, the cluster autoscaler will then take care of the rest. The next thing that I want to talk about is node pools. And when we talk about node pools, we give you an option to create multiple node pools on AKS. We require that one system node pool is there. So when you create a node pool, by default, it's a type system. And then you can create more than one, or as well as more than one user node pools as well. So all your operations, whether you do a scale, you do an upgrade, everything is done at the node pool level. You can also add taints, as well as kind of set node affinity at the node pool profile. So what that will do is, if, let's say, you want to make sure that I have a particular node pool which uses, let's say, a Windows OS, or it has a higher CPU, and I only want certain applications which require those CPUs to be put across, I can go ahead and provide those taints as well as node affinities. And then when I'm deploying my applications, I will need to have respective tolerations or node affinity labels, so that the applications will only be scheduled by Kubernetes on a particular node pool. Now, this works out efficiently well. In fact, what we've also seen customers do is they provision a completely new node pool of spot virtual machines, and that's how they can also optimize on their overall Kubernetes cluster cost, because pods are extremely cheap. And if you've set it up with an auto scale, what this will mean is that even if a particular spot VM is taken up back by the cloud provider like Azure, we will reprovision it, because there's cluster autoscaler which will always look at how many nodes are available and will reprovision it for you. The next thing from a scaling perspective is something called as KERA. So KERA is an open source utility which has been built by Microsoft and Red Hat jointly. The concept about KERA is that you can trigger the scale of your pods based on an external trigger source. Now, this trigger source could be a wide variety. I mean, if you go to the KERA site, you will see that there are various types of messaging components as triggers. So So you can trigger based on queues coming to RabbitMQ or Azure Service Bus, or you can even trigger it based on certain Azure Monitor fee metrics. Or let's say if you want to trigger it based on any external events, you can go ahead and do that, standard HTTP ones and those things as well. What this helps you do is, it also helps you kind of provision zero resources of your application, and you are only having KEDA installed inside of the cluster. And then whenever that particular external event gets triggered, KEDA can go ahead and create the first pod and then also scale it based on the necessary metrics to end pods, depending on how much kind of load or request have come into the particular external trigger source. So this comes in really helpful for workloads that, let's say, have a period of time where they're not going to be used at all, and you only want things to be triggered when there is a message which drops into your system. You can actually go ahead and scale them to zero, and then KEDA will trigger in whenever it is there. The next thing that I wanted to highlight from a scale perspective is ACR Geo Replication. So when you deploy your container images, you deploy it from an Azure Container Registry. And what we give you with out of the box with Azure Container Registry is you can just enable Geo Replication with a single click, define the regions, and behind the scenes, we will make sure that any images that you push, we will synchronize it across all of those registries, all of those regions. So what this means is that each of those regions now has a copy of that image. So when you are scaling your application, let's say your applications are spread across multiple geographies, uh, the application, the registry which is closest to where the application is deployed, the image will directly go ahead and get pulled from that part, which means you're spending you're reducing the amount of time that you will take to fetch a new instance of that image and bring it into your local cluster, because there will be a network close deployment, a network close registry which is there really close, and I will directly pull it from there. So that improves on your overall scalability and latency of your deployments as well. And plus, this also makes sure that it's highly reliable, which means even if a particular region goes down, I can always go back and pull it from the other region. By the way, the URL does not change. The URL is the same, irrespective of whichever region you're pulling from. We handle the network close deployment behind the scenes. There. So moving on to the DevOps area, I want to give you first a high-level overview of how you can implement end-to-end DevOps, and then I'll talk about the new cloud-native trends that we are seeing. So traditionally, what we've seen is there is this whole inner loop development, where let's say a developer is working locally on their laptop or whatever. He builds out a particular container. He can deploy in kind of an AKS dev cluster. We give you, if let's say you're using something like a VS Code, we give you remote debugging and capabilities directly out through VS Code. So you can actually connect it to a cluster, an AKS cluster running on Azure, and debug it directly from your VS Code IDE. So you know that my application, how it is running, what's happening, I can start debugging it directly. Once, let's say he's completed, tested his code locally, and he checks in the code into source control, you can trigger, and let's say this could be GitHub or any other source control as well. You can trigger your build pipelines, which will, build the necessary application, containerize them, and push it to a container registry. Now, this could be Azure pipeline, this could be GitHub Actions or any third party also, that's fine. And then let's say if you're pushing it to an Azure container registry, the image, then what you can do is you can have your YAML definitions, which can get triggered based on the container registry receiving a new image. So what will that do is it will trigger either your Helm chart or your your YAML definitions, depending. I mean, we recommend Helm charts so that your values are your dependencies are taken care of, as well as your values are parameterized automatically. And then your Helm can then trigger the deployment of your applications inside of your AKS cluster. In fact, if you want new AKS clusters to be created, you can use something like Terraform, which can provision resources for you, including AKS. And then Terraform can then trigger your Helm chart deployments as well directly. So with this, this is how you can achieve like your end-to-end DevOps automation, so that the developer is only focusing on his local development and then checks in the source code, and everything else is taken care of by automation, which is there. Now, what we have seen lately is a new things come up, which is GitOps. GitHub was started off by a company called as VWorks, but the idea is that just like your source code, Git is the central source of truth for any particular system. All your YAML definitions, everything gets deployed or gets stored inside of Git, and that means any changes that you do in those YAML definitions, everything is being audited and being watched. You can even put in the necessary review checks which are required, okay, and also put in like necessary approvals. So once this happens, then you can go for a push or a pull model. But then we've seen the pull based model being really effective, where let's say once you have your image inside of your registry and you also have your YAMLs which are deployed to your Git repository, you have an operator which is sitting inside of your AKS cluster, which continues to kind of poll and look at or listen onto the image registry as well as the repository. And if it sees that there is any change either in the YAML definitions or in the image, it can go ahead and trigger a new deployment internally and do that deployment, and eventually you have a new deployment of your application running without you trying to trigger the deployment yourself. So this is more like a pull based model. This comes in really helpful, especially in multi-tenant scenarios where let's say I have got 3 or 4 AKS clusters and I don't want to kind of repeatedly deploy in each one of them one after the other. I don't even want to create different pipelines with different kind of values so that each one of them has their unique deployment. I can go ahead and just do it from site inside of that cluster, and this will directly pull the deployments which is there. The other thing that what we've seen work out effectively is blue-green deployments, and AKS helps out amazingly well. Obviously, there are multiple ways of doing blue-green deployments. I mean, if you are familiar with Azure, this is very much similar to the concept of deployment slots. And there are multiple ways of doing these blue-green deployments. You can actually do it via your ingresses. You can do it via, your service mesh that I, kind of talked about before. But at the simplest level, what you can do is you can have a deployment which is hosted inside of your cluster. This will have a service associated to it, which is there. In the selector, you have a version number. Then what you do is you create a new deployment, which is essentially the green deployment, okay? And that comes with version 1.11. And once you have the green deployment up and running, let's say it has also warmed up, there is no cold starts, then you can just swap or update the service specification so that your version is updated to 1.11, and then your service is now pointing to the green deployment. Now the same concept, you can do it at the ingress level and make a new ingress updates. You can do it at the service mesh level and make just a new policy configuration there. So all of this is what I would generally recommend when you are deploying your applications. In fact, we've seen some customers also implement canary releases through that, where they can still have both the deployments running in parallel, and slowly and steadily I can start removing my, my blue deployments, but have some amount of workload still going to there, as well as some workload going to the newer deployment as well. Moving on to security. Again, if you remember at the start, I mentioned security has to be multi-level, and that means when it comes to cloud native application security, you have to do it at multiple places. Now, the first thing that we recommend is that you shift left, and that means rather than security being an afterthought and you kind of doing a vulnerability testing towards the end, you start looking at security as when you're actually developing your application. So, for example, What we know is we have got with GitHub, you have something called as GitHub Advanced Security, and when you use that, what it can do is it can start scanning through your application code when you're checking in, and it can look at any open source software, any vulnerability which is there inside of it. It can also look at, let's say, if are you checking in any secrets or any kind of sensitive data inside of your code. It can look at dependencies and start identifying which dependencies of yours are vulnerable. So you can start looking at those security vulnerabilities directly at the code level. Now, once this has happened, and let's say your application get built across and you have a new image, you can use the security integration between Azure Container Registry and Azure Security Center, where each of those images can again be scanned for vulnerabilities, and those vulnerabilities get highlighted there in themselves only. And you can define a policy which can say that if those vulnerabilities are there, I'm kind of not going to allow it to be deployed inside of my AKS cluster. So you are making sure that my containers that are eventually available for AKS from the container registry are absolutely secure. And then inside of my Kubernetes, I can implement you know runtime security using again integration with Azure Security Center, so that it starts looking at, are there any runtime. It basically looks through the logs and sees, are there any anomalies that are present inside of the cluster. And if, let's say, they see that a particular pod is behaving weirdly, they will go ahead and highlight it then and there itself. So that's how you kind of have an end-to-end security, right from your coding to actual your security inside of your applications, which is there. The next thing specifically I would want to talk about is with secrets. Kubernetes gives you a way of storing your passwords or credentials inside something called as Kubernetes secrets. However, when you want to deploy the secrets, you will need somebody who is having admin access to the cluster, and then that one also has access to the secret. So in order to have clear separation of concerns, what we recommend is that you secure those secrets by using Azure Key Vault. Now, this Azure Key Vault will have the secret values, and you can have different values for different environments. And then you use the role-based access control using Azure AD, so that from your cluster, only the right cluster will be able to fetch the right key value pairs. And you are only configuring your key vault in such a way that I'm only allowing certain Azure AD credentials to access a particular key value pair. Inside of the cluster, then the administrator only goes ahead and configures Key Vault, saying, hey, these are the values that I will need Key Vault to provide to me. Here is the credential which Key Vault will require. And these could be managed identities or custom service principal. Or if you want to go a little more higher, you can do pod identities. And then you start, kind of using those credentials across, which is there. Finally, we come to the manage bit, and that obviously includes monitoring. So one of the best features inside of AKS is the AKS Intelligent Diagnostics. What this means is that you can, let's say you go on, uh, you start clicking on, diagnose and solve problems inside of your cluster. It will start giving you these cluster insights, uh, and you can go ahead and then start looking at, how is my node ready, how is my node health, is my application having a lot of issues. It will highlight, let's say if you are having a lot of out of memory exceptions, it will go ahead and highlight those across. If, let's say, your applications are on an older Kubernetes version and there are deprecated APIs, it will go ahead and highlight those as well. So you start getting a lot of those intelligence out of the box directly from AKS, and you can be rest assured that all of those is identified by Kubernetes upfront or AKS upfront, and you can kind of start fixing them even before your customers report those issues, which is there. The next thing you can do is obviously use Azure Monitor, because with Azure Monitor, we give you something called as container insights. And that means we can kind of do an end-to-end monitoring of your application, the underlying infrastructure, the AKS platform, as well as, let's say, if you want to do any custom monitoring, you can introduce application insights, which can kind of capture custom metrics from your application. We give you a very good visualization capabilities by way of dashboards, and you can customize the dashboards. You can also integrate with Power BI, and we give you both out of the box workbooks, which are like templates that are available, as well as you can create your own workbooks so that a lot of those metrics and things can be kind of put across. You can do custom queries using log analytics using the custom query language, and then you can also set up alerts, which means you pick up a metric, you define when do you want to get alerted based on the threshold values of the metrics, and then you define the aggregation criterias that are there, what is the condition, what is the period that you want, and then you define what you want the alert to do. So this could be action groups. So this could be simple as sending you a notification or an email, or it could be like invoking a webhook, which can actually do certain actions as well. In fact, we've seen sometimes you other people go ahead and invoke a logic app workflow, which can actually go ahead and kind of do something else, right? Like provisioning a new cluster, or kind of updating your DNS values so that it switches to the new cluster. And then finally, you can integrate it with, I already talked about Logic App, but then you can integrate it with third-party systems like Event Hubs as well. From a management perspective, Kubernetes needs to be upgraded regularly because the upstream releases are happening once every, kind of 3 to 4 months. So we will recommend, you implement something called as auto upgrade. This is just like when you create a cluster or an update a cluster, you provide the parameter of -- auto upgrade channel, and you select a channel. And this channel, if you've selected as none, means you do not want it to auto upgrade, but then you can define various settings inside of auto upgrade. So these settings could be, let's say, rapid, which means we will always upgrade to the latest release, minor version, and the patch, which is there, and you are kind of up to date. But then let's say you don't want to be very immediate, you want to be a little cautious, and you want to go for the N-1 release. So you go ahead and pick up stable. And then when stable is picked up, we will make sure that we are on the N-1 N-1 releases, but we will obviously go to the latest supported patch release in that N-1 minor release. If you go for patch, what it will mean is we will always go to the latest supported patch, but the minor version is not updated at all. It stays on whatever it is there. This does mean that there could be a very small chance that you can actually go out of support because you are in an older N-1 version. And then finally, you have node image upgrade. So we release a new version of the node on a regular basis based on how many patches have been applied. So what you can do is, if you just set it as node image, every time that this new node image comes across for your underlying worker nodes, we will automatically upgrade those for you as well. Now the interesting bit is also another feature called as planned maintenance. And what you can do with planned maintenance is define windows when you want these upgrades or these things to happen. And we will ensure that only during those windows we will do these upgrade operations, so that whatever node reboots or even your pod reboots needs to happen, they will happen during the planned maintenance windows. Do remember, I still strongly advise that you should kind of build your application such that even if those node reboots or pod reboots happen, your application is still kind of resilient to those changes. So with this, I come across to my reference architectures. We've got this set of amazing documentation. I will not go and cover those reference architectures, but essentially if you go to search for AKS secure baseline, or go to the GitHub repo, and you will get an out of the box setup that you can implement, which also gives you the necessary guidance around networking, security, and identity management, monitoring of the cluster. And we basically tell you, right, what are your patterns, how do you want to go ahead and implement it, and what are your considerations, and then decide on the right approach of implementing those things as well. We also have, let's say, if you are on regulated industries, let's say for financial services, we give you a reference architecture for which is more compliant with the payment card industry standards, PCI DSS. So you can go ahead and implement those controls directly out of it. Again, that is available on the GitHub repo along with explanations. Go ahead and have a look at those. In case if you want any further, kind of reading, the AKS, kind of release notes and roadmap is there publicly available. So you can always go ahead and look at the roadmap and see what features we are releasing on a regular basis. We also publish release notes. Our AKS releases happen like, every at least once a month, if not every fortnightly, and which means you will see those release notes tell you what are the issues, or what are the fixes that we bugs that we fixed, as well as what are the new features that we are releasing across the world. So with that, I am done with my set of slides. In case if you want to kind of learn more, there is a Kubernetes learning path which is available at various sources. There are videos that are there. You can kind of also look at case studies from customers and do a free trial as well. So I am now at the end of my presentation. Again, feel free to drop me a note in case if you have any questions. Let me see if there are any questions that I can address. Okay. What is global black belt? This is a term, an internal, kind of group inside of Microsoft. We are not karate experts, but yes, we are experts in like cloud native application development. So that's where the term is there. What is HCI in Azure? I'm assuming when you say HCI, you're referring to, so there are two scenarios. One is, when you're talking about, you want to implement or pick up Azure, but you want to have it in a hybrid controlled infrastructure, which means the infrastructure is completely controlled in your control, kind of in your on-premises environment. You go ahead and pick up an HCI setup and you manage it just like you are managing an Azure environment. And when you are using the HCI capabilities, you can deploy AKS inside of the HCI setup, just like you would be deploying AKS on Azure, which is there. Google is not in the cloud providers list. Maybe it's a mess, but yes, I mean, if you're referring to, multiple cloud providers which we can use for managing, yeah, that's there across the board, and for KERA as well, which is there. When should we need service mesh? Very, very complex questions. I already talked about a few scenarios. Let's say you want advanced traffic routing, which means, I want to do canary deployments where I want two services, one service to get 10% of my traffic, other service to get 90% of my traffic. I can go ahead and implement that using service mesh. Let's say I want pod-to-pod communication to be completely encrypted. I can implement mutual TLS using service mesh, and I don't need to install anything. I just go ahead and configure the service mesh to say, hey, for this namespace, please implement encryption. Here is a certificate. What service mesh will do is make sure that the underlying site containers are now ready with that necessary encryptions, and they will go ahead and manage the encryption for you. How to define infra number of VM pods based on workloads? Let me come to that topic a little later. Let me go ahead and address some of the other ones. How is migration of Kubernetes from one cloud to another? How is the decision made in a big organization? Typically, the benefit of Kubernetes is that it is stateless. You have your container registry. You can go ahead and move your containers from one registry to the other. Most of the registries give you a import or a sync feature so that you can sync from other external registries, and that's how you can go ahead and do it. Obviously, I would want you to stay on Azure because Azure gives you Geo Replication out of the box, which means wherever your container, your deployments are on other cloud platforms, you can have a nearest Azure container registry for it. But then, yes, you can do that, using container registry and then just deploy another Kubernetes cluster. In case if you have some state which is stored inside of the traditional storage. You can use things such as VMware Velero, or there are some other tools available which can help you kind of take backup of your storage as well as the underlying kind of pod data, and then restore it on the other region. But then I mean, it's only required in case of highly complicated scenarios. Uh, is there any way to track the costing of AKS? AKS gives you very good ways of, or actually, I will put it this way: if you use the Azure cost analysis, it already gives you a way to track cost of your AKS cluster at the resource group level, as well as what resources are being used across. If you want to track costs inside of AKS, there is this tool called as Cube Cost, which can help you. I you know we've we've not had any specific feature that we put across inside of AKS. Uh, the next one is service mesh. I believe I have already talked about it. Istio is one type of service mesh. Linkerd is another type of service mesh. There are multiple service meshes that are available in the industry. Azure has a managed service mesh offering called as Open Service Mesh, and the whole idea is that what I would recommend is pick up a service mesh that conforms to the SMI standards, which is the service mesh interface standards, so that if you want to do an interchange of service mesh, it is much easier to do it. You can pick up any service mesh which is required, as long as all your necessary requirements are taken care of. So with this, let me go ahead and come back to Krishnendu's question about how to define the infra number of VMs pod based on workloads. If it's a pretty complex kind of discussion, but let me go ahead and try and put it across. Let's say you are running your application, right? When you're running it locally, you would have determined what is the minimum kind of CPU or memory that my application requires, and when it starts scaling, what is the limit after which the response time starts kind of skewing up. So I know that the minimum required CPU is, let's say, 100 milli CPUs for my, and then for my, when my application starts kind of my latency in a particular instance, a single instance starts going slow, that is when at like 1 core. So I know that these are my limits, and after which I will definitely have to introduce multiple instances of my containers. So what I would generally do is keep the request values as the minimum, and then have a limit value which is, as I had recommended, closer to the request values, and then you keep your scaling in such a way that you scale to the maximum threshold. Let's say when you're doing your performance test or your stress test, what is that maximum number beyond which your application starts failing, mainly because the underlying database is going bad, or the overall throughput is not the things that you expect. So now you have that value at your individual container level. Then when you are deciding on your cluster, pick up all your application pods with their minimum values, and we generally always recommend 3 instances of your pods. So if you're going by that practice, your 3 instances, whatever is the minimum, get the total. You will get like a total core, maybe 30 cores, 40 cores, whatever is there. That is your kind of your cluster autoscaler minimum. But then you have to look at the VM density. Now, if let's say your number of pods, there is a setting called as max pods per node inside of your Kubernetes cluster. So it can be a minimum of 10. The default value is 30, and then you have a maximum of 100. Actually, maximum is 250. So what you can then do is, depending on what are your CPU requirements, you can decide that value, and then you decide on your node configuration based on how many number of pods you want to squeeze in inside a single node. And then I would always recommend 3 nodes for high availability, and that's how you can then eventually limit your maximum number will obviously be your max number of cores that you come up inside of your cluster. I hope that answers your question. Feel free to drop me more notes. I believe we are on the top of the hour, Rohit.
Yeah, we are actually good. So it's just 6, and I think we're good. And guys, like if you have any more questions, please drop your queries in the comment box. Also, Yusuf will we have shared this live YouTube link with you. So in case if you find time, you can go back and answer these questions. Also, so guys, there was a prerequisite learning link that Yusuf has shared with us before the session started. The
Yep.
same has been shared in the comment section. So do go through the link, and you will understand how to develop and deploy the application on Kubernetes. So yeah, go through it, and more learning links will be shared with you over the post event mailer. So I think that is all. And thank you so much, Yusuf, for joining us today and sharing your knowledge with us.
Yeah, sure. Happy to help out. And
Yes.
yeah, enjoy the rest of the evening or whatever is left of the day. And then have a great time. Thanks.
Yeah.
Bye.
Thank you so much, Yusuf. All right, so that was Yusuf. And before we wrap up today's meetup, so few things. As we all know, this meetup is part of Azure Developer Community, which is an initiative of 100 plus cities in India. So, in case if you haven't joined the community yet, so you can go through this link, which is azdev.community, and you can find your nearest community. So, join the groups and attend sessions to learn more about different technologies and services which Microsoft Azure is providing. Also, along with that, we are running a very exciting activity. So it's called Cloud Quizzing Challenge. Many of you might be knowing that already. So it's a live quizzing challenge that we are running, where we are encouraging developers like you to come and participate in Azure questions. So it happens every week on Friday 5 p.m. IST. So do join, guys, and do attend questions. And we have very exciting prizes for the winners. So there are prizes for the individual quizzes, and also we have a tournament leaderboard. So we have started with the quiz on 8th of October, and this will go on till 17th of December. So do visit the website and join for our weekly quizzes. Hope you will be liking that. And we regularly conduct these kind of meetup sessions. So do subscribe to the YouTube channel so that you get notification for all our upcoming meetups. And that will be all. So thank you so much, guys, for joining us today, and we hope that you would have learned something new today. So see you all again in our another meetup. So with this, thank you everyone. Have a good day.